you, Rasse. Thank you so much. And before I start, I want to thank you, Rasse, and especially Emilia and everybody who's been arranging this event. I was looking throughout the event for the whole day, basically peering into different things that everybody has been speaking about here. And I have to say that this has been one of the most sort of this has been an event that has had a bit of everything. And that's sort of the thing that we're going to need here today also, a bit of everything. We're going to need the things that we've spoken about, the UX design. We're going to need things like the security and so on. We're going to need the front end and we're going to need the back end development. So everything you've sort of learned so far by today has been valuable also for this kind of hobby, what I'm going to talk about. And let's see if this works. If I click here, nothing blows up, right? Good, okay, perfect. So my name is Mikko Kasanen. I work as a cloud solution architect at Microsoft. My main field is application development and actually cloud development, so I talk about Azure. What you see here and what I'm going to talk about today is mostly a hobby for myself. But it's also something that every single thing that I've built with these things that I'm going to be talking about has been some way been useful for me at work. There's been situation where there's an IoT company asking me, how could I do something like this and that? And then I said, actually, I have some code for you that you can just use. So it's always been sort of fun that I spend a weekend on something, a pet project, and then it becomes very useful. So you also see a drone here. I'm a drone builder. I'm a maker. In a way, also sort of like a hacker for the devices and everything. I want to always understand how something works. Also, I'm going to be a father of a daughter in coming spring. So I also want to thank all of you for making the world more equal place for her and that she can join your forces one day if she wants. So that's something that I'm very thankful for. So my objective today is not to show how you do this or that or so on. My objective here is to make you sort of understand that even though this right now looks very confusing, probably, it's actually very simple. You just need to learn a few key skills here and there and then sort of combine them together. The topic was embedded systems or embedded devices. And the reason for that is basically it's very hard for me to explain what all this is. This is a bit of IoT. This is a sort of Raspberry Pi type of device that you can use for many things. And the objective is to sort of make you understand that when this looks like a forest, you will find the individual trees and understand what their function is. That's the objective. To make things a bit more complicating, we're going to be talking about microcontrollers. There's also a term microprocessor, and it sort of relates to what I said earlier. Microcontroller is just the CPU, so it's meant to process some information that we give it. But a microcontroller is actually a sort of like a system, a forest. It has multiple things that one thing sort of handles. 98% of all sort of microcontrollers and chips actually end up in some sort of embedded system. And that's the cool thing. When we talk about like microprocessors or controllers, we usually associate them into PCs and things like that. But majority of everything goes into things like this. In this example, the idea is that if you have a device that has more than just a power button, it probably has some kind of microcontroller in it. And for me, that's exciting because then it means I can hack things. Because when we start to understand the trees, individual trees here, so the tree being for example, the microcontroller here, then we can sort of modify it to our needs. In the picture, you see an image of this fan. It's not a clock, but it's actually a fan that blows air. But you see a picture on it, you see an image on it, you see a clock on it, meaning that in that fan, there is some kind of a microcontroller. I think I was in 2016 in Florida in our conference, and they were handing out these small USB fans that had a button, and you click it, and the fan starts to spin, and it said Windows 10 on LEDs. Here is that device. So I have actually dismantled that. There is a small microcontroller in it. And when I dismantled it, there is also pins that I can leverage to basically program these LEDs to do something that I want them to do. It makes me, I'm curious, so it makes me wonder, how does it work? There's only like 7 to 8 LEDs here. How can it print text? So my point is, every time I dismantle something, I learn how it's designed, how it functions. And the function in this is very simple. It is attached to a motor. It spins at a certain speed when we give it certain voltage. And these LEDs light up just in the right position, and that will form as an image, for example, that you see in that clock there. And that for me is so cool because the function is so simple. This device is super simple, and it teaches me everything from like hexacode that you need to have here to change the text into something else. But nonetheless, it's a very useful skill to sort of understand how this works. All right, so how do you get started? Let me look into my box. This one is an Arduino, and this one is an Arduino. So Arduino is this sort of, I don't know if it's actually meant for children to learn about electronics and things like this, but I highly recommend that buy it for yourself. Go to, let's say, verkkokauppa.com, which has these €99 kits that I've put up there. It has a ton of these sensors that you can use and sort of start working on. It has a good book and instructions on how to code a certain thing. It can be simple. It's very easy, and it's also teaching you how to code. So buy it to yourself, buy it to your kids, do it together, and really those things that you learn there will be highly valuable for you when you move on to building something like a cloud-connected IoT device. Everything, the Arduino code that you can do on these dirty, cheap things is transferable to this one. So that's why it's so sort of cool and important. But yeah, the Arduino programming language is actually very simple. It's good to learn. It's good to learn for programming. But if you're already sort of invested into things like C or C#, that's perfectly fine because these platforms typically support more than one language. Then another important skill for you is going to be something called breadboarding. I didn't bring my breadboard here today, because, well, I kind of burned it. So that's the thing. Breadboarding is basically taking like this Arduino, putting into, you see in the image, you see this white piece which has a lot of these holes. You plug it in, and then you take a sensor, like this is a simple humidity and temperature sensor. You put that into the breadboard, and then you begin coding. And then the beauty of the breadboarding is that your project instantly comes alive. You don't need any soldering skills. You don't need to have a ton of hardware or anything like that. You just put it in there, you do the code, or you use an example code. Arduino is full of that, and I want you to leverage as much as written code as possible because it really speeds up your learning. So with that, it's a safe way to sort of test if your idea works. So the thing is that with these embedded systems and devices, we will always want to sort of make them as simple as possible to deliver a certain function. So a breadboarding solution would be that we have a button on the breadboard and a LED light and an Arduino, and just a single line of code basically saying that when this button is being pressed, then turn on the light. And you get to see your code come to alive instantly. That's super cool for me. Then, if you're already sort of aware of a bit of this, you might have heard of devices like Raspberry Pis, or this one is actually called Asus Tinkerboard. It's a bit more powerful than a Raspberry Pi. This one that I have a LCD touchscreen attached to is a Raspberry Pi. But these are sort of they're also embedded devices, but they're somewhere between a PC and an embedded device, because for something like turning on a light, these are too powerful. So you're actually wasting resources. So you're wasting computational power that you could do with a much simpler thing. But then again, on the other hand, let me show you something. This is a small robot that I'm building to tease my dogs. So when you build these systems, you don't have to sort of have necessarily a reasonable function for this. For me, this idea is to use this to tease my dogs, to play with them. So it's just 2 motors, a 3D printed shell. This model has been taken from Thingiverse, and I haven't designed it myself. Here is a Raspberry Pi. This is just a bit smaller Raspberry Pi than the previous one that I showed. It fits better into that. It's a little bit, it's not that powerful as this one, but it's still very good. And the cool thing is that with this, I can sort of make this thing move. I need a motor controller, something like this that I have here, but I can also connect this to internet. So I could use my mobile phone to run this. I don't need any radio controls or anything like that. So I can actually keep the project rather simple. When we have the skills that we've developed from the Arduino testing, we have already learned how to connect sensors like this. This is an ultrasonic sensor, so it detects a distance. So if we would turn this on, it would tell me probably that there is a wall 1.5 meters away from me. When we combine it with this robot, then we have eyes for it. It's not a camera, but then it has a way to detect if it's going to collide with something. So we can actually make then our robot a bit more autonomous. All these are things that you learn from doing these pet projects over the weekend. And that's sort of, I'm building you towards the superpower that I believe is when you have interest into things like this. I mentioned IoT a little bit. For me, I just want to use a second for this. IoT in a nutshell is when whatever we have here is connected to internet or connected to a different device, that's IoT. IoT means Internet of Things. Internet of everything. Everything connected to internet. Your car being connected to internet is basically an IoT device. So when you see IoT in a job description or something like that, understand that it's just sort of trying to say that we want you to connect something to internet or to a different system. It's not complicated. Don't get scared of it. On our virtual stand, there's people that you can ask of this, but we do have this free Microsoft virtual training days, which does not dig into only the IoT thing, but basically our Azure offering. So we have, I think it's like every 2 weeks or so, there's the schedule. I cannot actually see it from this screen, but there should be one starting probably next week. And through that, you get free training and also a voucher to certify yourself towards that I know Azure basic fundamentals. And that could be very valuable for you if you're applying for a job, for example. Okay, then we got to speed up things a little bit. Here is an ESP32. I highly recommend that you look into this as well. Super cheap. Let me explain how cheap this is. This device costs $5 ordered from China. This device has Wi-Fi, this device has Bluetooth, this device actually has quite a bit of computational power. $5 for this kind of thing. Everything you've learned from Arduino can be used here, basically. What I've done here is I've just combined this. This is a GPS chip. So this connects to GPS and also GLONASS satellites. And it gives basically information to this board, where am I? With this, if I hook up this battery, it will start searching for the satellites. It will start doing sort of its function. And all the code that I have here is already sort of freely available by the community. I really, really love this as a sort of brains for any homemade IoT project. If you want to automate your home, this is a great place for that. I have like a sensor that detects moisture on soil, so this could be your brains for an automated greenhouse or stuff like that. The things that you can do with this kind of super cheap device is amazing. And the point here is that why I would use this and not Raspberry Pi, because this kind of application with the moisture sensor does not require that much computation, so we would not be wasting resources. Let's pair these Raspberry Pis into something else. Then I've already showed this a little bit. I want to show it one more time. So this is a IoT development board. So this is sort of something, if you work in a company and you have plenty of people developing sort of IoT solutions towards cloud, I would get something like this, because then every developer has a similar platform to do their work and to code towards to. This device is not something that I would necessarily put into production. It has these pins, which means that I could add it to be a part of a bigger embedded system as the brains. But then again, we might be wasting this. This has every single sort of sensor. It has an accelerometer, I don't know how to pronounce that properly, but basically detects the motion and the angle that this device is at. It has also a security chip. This has been something that we have discussed throughout the day earlier. Very important. It has a sensor to detect magnets, and it has a sensor to detect the air pressure, the temperature, humidity, and all sort of stuff like that. Super cool, but not necessarily the basis for your home project. Very briefly, when I showed you this ESP32, I have an idea of where I'm going to use this. I already mentioned that I'm going to be a father in spring, so I want to use this to build a baby monitor. When I thought about this idea, I already found a code that I can use. It can connect, like the designer has shared the code, and he has connected already, or she has connected gas sensors and humidity sensors and all kind of stuff like that, in addition to the function that it's going to perform, which is to monitor the baby. It doesn't mean that I have to start the code from the scratch. Even though it's very educational, it's also educational to look into how other people have done that. So that's going to be my personally next project, basically. Then let's go even further. We want to build something all the time, simpler and cheaper, simpler and cheaper. Cheaper does not always mean money. I've been talking about using those resources. There's an image of this AT-Tiny85 chip. That's the smallest chip on that board. It has a integrated USB port, so you can plug it into your computer. Those small dots, which I have marked as I/O, are basically places where we can put these sensors that I've showed earlier, this ultrasonic sensor or the gas sensor or whatnot. That device, if you order that, basically that chip that makes that device cost 64 cents from a Finnish retailer. So that means developing these things is also very cheap on your wallet. When you get further with this, let's see if this changes. Yes, good. This is also, by the way, a sort of embedded device. So when you have this idea that, okay, I've done Arduino, I've done Raspberry Pi, I know how this thing goes, you can challenge yourself a bit more. Since I'm running a bit out of time, I will very quickly go through these last things, but these are sort of the next step for myself that I'm trying to learn. The thing is that there's these free software that allows you to design these things. When I show you this board, this piece of fiberglass with all these chips embedded in is called a PCB, so a printed circuit board. Back in time, people did these kind of projects on these breadboards or these solderable boards, and they did them by themselves. Nowadays, you can use this CAD software to design the schematics for this, and then order them from any sort of store, or not store, but manufacturer in China. And printing out a board like this can be very, very cheap. like you can print boards for less than $2 a piece. And you have a ton of like material to support you, and even the factories. When I was designing a board to distribute power to a motor on a quadcopter, this is also an embedded device. When I was designing these and I sent the schematics to China to the factory, they actually replied to me saying that, hey, we found an issue with your design. The power is not flowing correctly, or it is flowing correctly but not enough. If you do this change, it will perform better. So you get this amazing feedback from them. Lastly, because we're going overtime very soon, YouTube is an actual goal of mine for this kind of learning. I want you to feel a bit inspired that you have all the skills to start this. You have already most of the skills to build anything like this connected to the cloud. Even just by attending this event, you have gotten that. I have put up a link there to a 2.5-hour sort of lecture that goes through the whole process of designing something like this, from scratch to actually being mailed to you, built in to your mailbox. Finally, the skills of an embedded superhero that I wanted to say. I want you to be able to define a simple function for a device, and I want you to feel that you can do that. I want you to have a good search engine skills to find the schematics to circuits like this ARM chip that we have here, because once you find that and you're able to read that, you're able to hack it and do whatever you want with it. Then you actually understand it very well. I want you to be able to solve visual problems, because fitting a lot of stuff into a board like this actually requires a bit of like dimensional thinking, because this is not just one layer, there are multiple layers in it. And these are all skills that you will learn through your journey. I also want you to be ethical. This kind of device is harmless when it says Mikko on the screen. But this device with a change in the code, with a code that's readily available, would be at this moment scanning all the Wi-Fi networks in this room and trying to hack their passwords. That's your superpower, and use it wisely. You can do so amazing things with these, but use them ethically and use them for good. That's my ask for you. Otherwise, I think we're pretty much good with this. Thank you for this, and come to our booth to talk to us and ask if you have any more questions. We're trying to arrange actually some kind of IoT workshop for like Mikko in the springtime, if the pandemic gives in a little bit. Perfect. Thank you, and have a great weekend from me. Bye.